Assalamualaikum everyone. We are going to present to you about contemporary sea level rise rates around Malaysia, altimeter data optimization for assessing coastal impact. This poster has been prepared by our group and we are all marine science students. I am Nurik Hafiz bin Zambri and we have Muhammad Aiman bin Asrafendi, Muhammad Ani bin Ismail and Muhammad Yusufami bin Abdul Halim. Now, let's proceed with the introduction. Sea level rise is a critical of climate change, threatening coastal ecosystem, infrastructure, and communities. In Malaysia, with its extensive coastline, accurate monitoring of sea level changes is vital to address risks like flooding and coastal subsidence. Traditional method of measuring relative sea level (RSL) changes struggle to separate sea level rise from land motion, making it harder to pinpoint the true causes of change. Our study tackled this issue by using advanced technology like satellite altimetry, GPS, and PS INSAR with 19 years of data. We aim to provide clearer insight into sea level trend to support sustainable coastal management.
Okay, for the research background or the problem statement, so the measurement of the sea level change is complicated. This is due to the interaction between global climate effect and the local land movement. These factors can significantly impact how we understand sea level rise. Traditionally, we have relied on tide goggles to monitor relative sea level or RSL. These goggles measure the height of the sea in relation to the land, combining both sea level change and vertical land motion or VLM. However, RSL measurements alone do not distinguish between sea level change and the land movement. This can obscure important climate-related change that we need to identify. To overcome this limitation, our study integrates data from multiple resources such as satellite, altimetry, GPS, and persistent scatterer interferometric synthetic aperture radar, also known as PS in SAR. This multi-sensor approach provides a more accurate picture of sea level change. One significant finding is Malaysia's lack of multi-sensor studies that quantify both VLM and absolute sea level or ASL trends. This highlights a critical research gap that needs to be addressed for better understanding and management of sea level rise in the region.
Now, let's move on to the objective. Our specific research objective has three. Number one, to quantify absolute sea level using optimized satellite altimetry data, focusing on sea level rise around Malaysia coastal region. Number two, to analyze the key factor influencing sea level rise, including thermal expansion, ocean circulation, sediment and land movement, to understand their impact on Malaysia coastal zone. Number three, to integrate relative and absolute sea level data to provide a comprehensive view of contemporary sea level rise, rate, and their coastal impact in Malaysia over a 19-year of period.
Let's move on to the literature review. The literature on sea level trends in Malaysian water has significantly enhanced our current understanding of the factors that are influencing sea level rise through the application of satellite altimetry and analysis of tidal data. Recent studies strongly stress the optimization of altimeter data to accurately work out the contemporary sea level rise rate and their impacts on coastal ecosystem. A newly developed important methodology concerning multi-mission satellite altimetry and vertical land motion corrections seem to be offering comprehensive insight into changes in the sea levels, considering natural variability and anthropogenic forcing. This also underlined that the contribution of improved monitoring technique to decision-making for coastal management would be highly useful and might become necessary as part of building resilience in sensitive coastal zone, considering a sea level rise Overall, this body of work underlines the need for continued research and the development of advanced methodologies to address the complexities of sea level dynamic in Malaysia's water.
Next, for the research methodology, we have three parts, which is data collection, robust field regression analysis, and the trend estimation. For the first part, which is the data collection, the study used satellite altimeter data and tidal gauge data to analyze sea level anomalies, or SLA. The altimeter data is processed to remove noise and outliers, ensuring that the analysis is based on reliable measurement. Second, robust field regression analysis have three subparts. First, linear projection. The SLA time series are predicted using a linear function, which serves as the foundational model for trend analysis. Second, outlier removal. Outliers are handled through iteratively reweight least square, or IRLS technique, which enhance the robustness of the field by minimizing the influence of anomalous data points on the overall trend estimation. The third one, model validation. The reliability of the satellite altimeter data is checked against tidal gauge measurements. The connection between this dataset is evaluated using statistical measures like the root mean square error (RMSE) and correlation coefficient R values. A strong correlation R value around 0.903 indicate that the altimeter data is consistent with the tidal observation. Next, with the third part, the trend estimation. The robust field regression method is used to estimate sea level rise rates over the specified periods. This method optimizes solution determination and effectively handle outliers, providing a more accurate representation of long-term trend compared to traditional least square method. For instance, the South China Sea show a stable increase rate approximately 3.88 mm per year, while other areas exhibit more irregular pattern due to geographical influence. Lastly, so the estimated sea level rise for various areas is calculated, showing the clear pattern across different seas.
So next, I will cover the part result and discussion. So the absolute sea level rise rate is different across each of the sea. The Celebes Sea has the highest rate at 4.95 mm per year, while Malacca Strait has the lowest rate at 3.27 mm per year. There are more variability or challenges in data collection for Sulu Sea and Celebes Sea, as the uncertainty values for these two seas has the highest value among four seas, while South China Sea have the lower value that shows the higher confidence in the measurement for this sea. And the mean absolute sea level rate across all of the seas is 4.22 mm per year, which aligns with the global issue of rising sea level. So next, the sea level trends across all four seas shows a consistent upward trajectory over the period from 1993 until 2015. Celebes Sea showing the steepest trend, while Malacca Strait is the shallowest. So the red line shows the significant oscillations that shows seasonal and interannual changes that influenced by climatic factors like monsoons and so or local hydrodynamic conditions, while the blue lines smooth this variation, that highlighting that long-term trends while accounting for variability. So next is the Celebes Sea recorded the highest total sea level rise of 0.056 mm, and then which aligned to the annual rise rate. The average sea level rise across all the sea over the period is 0.053 meter. And there are three possible factors that contribute to the sea level rise, which is the first one is thermal expansion, where the Celebes Sea is the deeper and more exposed to open ocean currents, and it will heat up and expand more and experience greater thermal expansions due to warming water. And then the second one is the ocean circulation. Celebes Sea and Sulu Sea has a stronger currents that bring more water into this area than cause rising sea levels. And then the last one is the sediments and land movement. In shallow area like Malacca Strait, sediment from rivers and lands sinking can make the sea appear to rise faster. And then even we can see it is just a small increases of sea level, but it can give a big impact to the earth, which is such as flooding, erosion, and also habitat at risk due to the sea level rise. So that's all from me. Thank you.
To conclude, these studies of sea level trends in Malaysia's water have identified the urgent need for advanced satellite altimetry and tidal data to assess accurately the contemporary sea level rise and its implication for coastal management. Optimizing altimeter data and integrating it with vertical land motion corrections allow this research effort to uncover substantial insight into the dynamic of sea level changes that are influenced by both natural processes and human activities. The findings indicate that there is a need for better methodologies in monitoring sea level to inform adaptation strategies and enhance resilience against rising sea level in vulnerable coastal regions.